Marsdale District Heating is a privately owned company established in 1962. The plant supplies the town of Marsdale and the outlying village of Kreiswinge with district heating, and today has approximately 1,400 customers connected to its 30-kilometer long pipeline. Between 1962 and 1988, the heat produced by the 6 oil-fired boilers was based on fuel oil, but in 1989 it was changed to run on waste oil. In 1990, a smoke cleaner was added to remove particles in the smoke from the waste oil. The idea of solar heating came when Marsdale District Heating was investigating the possibilities of using biofuels instead of waste oil in its heat production. A project analysis showed that the plant, with 8,000 square meters of solar panels and an accumulation tank of 2,000 cubic meters, would cover between 13 and 15% of the heat requirement, although in the 3 or 4 summer months the coverage would be 100%, even with the added requirement that the temperature of the water leaving the solar panels would have to be between 70 and 72 degrees centigrade. To meet these demands, it was suggested that the plant be controlled by variable flow, so that a high temperature could be obtained even when the sun was not at its highest. This method was unfortunately not very well known. Marsdale District Heating had a desire to test the principle in a smaller scale before building a plant with 8,000 square meters of solar panels. And in July 1994, a 75 square meter plant with variable flow control was built on the top of Marsdale's local swimming baths. The test plant was built using the same skills and demands that would be made on a full-scale plant, and having run for just 6 months, the test results were so good that a decision was made to build full-scale, a total of 8,038 square meters. The plant was completed in 1996, and after the first 2 years it was accepted that the plant could not cover 100% of the heating requirement in the 3 summer months. Therefore, the plant was enlarged in 1999 with another 1,007 square meters. The 9,045 square meters of solar panels would now cover approximately 15% of the total heating requirement, but could still not cover 100% during the summer months. Therefore, a decision was made to apply for funds from the European Union and the Danish Energy Authority for a new project called Sunstore2. This project received subsidies from the European Union and the Danish Energy Authority, and today totals a massive 18,365 square meters of solar panels, plus an extra 10,000 cubic meters of accumulation tank. The Sunstore project started in 2001 with the project meetings and discussions with Marsdale District Heating and their cooperation partners. Cooperation partners in the Sunstore project include ITW from the University of Stuttgart in Germany, CIT Energy Management from Sweden, and the Danish companies Rambøll, Arcon and Plan Energy. At these meetings, decisions were made as to which solar panels would be used in the project. The final decision based on price per productivity in comparison with Arcon solar panels. The extension of the accumulation tank was also constructed after a workshop with cooperation partners and experts from Germany and Denmark who oversaw the meetings. The area on which the solar panels would be constructed had to be examined for historic activity before any construction could take place, and Langeland's museum dug long trenches all over the area, but found nothing of interest. With the completion of the museum examination, the area had to be levelled and prepared for the construction of solar panels. The terrain was raised by about half a metre, with earth from the area, which would later contain the new pit heat storage. Surveyors controlled that the land had the correct gradient, and the foundations for the solar panels were laid. Before the solar panels could be assembled, the area had to be drained, and pipes for the collector field had to be installed. Also electrical cables laid to carry the data signals from the collector field to the computer system. Marsdale District Heating laid all drainage pipes in the area, in cooperation with the local contractors. All the pipes used in the collector field are standard central heating pipes, but with an alarm thread which would warn of any leakage problem. With the completion of piping and electrical work, the solar panels could be constructed. The Archon field was constructed between August and October 2002, and heat production from the field commenced in February 2003. The solar panels were made in Skopje and transported to Aero by road and set up. The technical centre, containing the technical equipment for Sunstore2, was constructed in the autumn of 2002 and completed on the 22nd of November. Due to the fact that pumps and heat exchangers have to be below the water level in the accumulation tank, the centre is built underground. The centre also contains the electrical and surveillance equipment which control the heat flow, and in addition a transmission pipe which connects the new and the old heating plants with the centre in Jagtvej. Pipe work in the centre was carried out by GJ Technique, who first assembled and tested the system in their own factory, then disassembled and reassembled everything in the centre. Wagner, as a presentation of integrated solar heating systems, integrated 103 square meters of solar panels on the roof of the centre. GJ Technique's 880 square meter solar panel field was put online in February 2003. These solar panels were produced at GJ Technique's own factory and installed directly from there. In April and May of 2003, the focusing solar collectors were also installed and put online by GJ Technique. By May 2003, the total area of solar panels had reached 18,365 square meters. Construction of the new pit heat storage commenced in June 2003 with the removal of 10,000 cubic meters of earth, and in July the hole was ready to be lined with plastic sheeting. Each sheet of plastic was doubly welded, and every weld was pressure tested. Pipes for out and return flow were welded in, and the tank was filled with 10,000 cubic meters of soft water. Just filling the tank took 32 days. After the tank had been filled with water, a lid was welded on, starting from the northern end. The lid was made of the same plastic sheeting as the bottom and the sides. With the lid completed and pressure tested, the work of insulating the tank could begin. First, a layer of vapor barrier was laid out of a type called alujet, followed by a geotextile. Onto the geotextile, 8mm reinforced iron was laid out and 100mm of insulation batting added. To ensure a correct slope for the lid, a polystyrene plate was fitted. To finish the lid, a roof liner was placed on top of the polystyrene plate. Work on the heat accumulation tank was complete in November 2003, but was first put into service in June 2004. As a completion of the Sunstore2 project, in September 2004, a workshop was held which all the cooperation partners attended, including guests from all over Europe. a total of 36 people from 7 countries. At the workshop, videos and pictures from the different types of solar panels in the Sunstore2 project and the pit heat storage tanks were shown. Production data from the different solar panels, plus drift data from the 10,000 cubic meter pit heat storage system was also available. Several other European projects were also presented, and after the presentation of the Sunstore2 project, participants in the workshop were invited to tour Marstel District Heating's 18,365 square meter solar field.
Thank you.